Hi everyone, in this video I want to talk about solving quadratic equations with the square root method. Here are the two problems that we'll do, and to make sure that we don't take ourselves too seriously, let's think about the fun question. If you had an offer to go to outer space for a whole year starting tomorrow, would you take it? Why or why not? So, quadratics are often introduced in Algebra 1 and then reinforced in Algebra 2. Quadratics require you to learn solving, graphing, and typically you would have some word problems in that unit. So for this type of problem, using something like the factoring method or the quadratic formula method, completing the square, it just doesn't make as much sense as it does square root. So I want to do an easier one and a slightly harder one for you here. So for the first one, I'm trying to get b by itself. And if I can take a square root of both sides, that typically is the fastest way. I love this idea because I don't have a b term. So it'd be a much different problem if this was like 10b right there. Okay. All right. So let's try to solve for b. The first thing I want to get rid of is not the 4 next to it. It's the 10 right here. Because if I divided both sides by 4, sadly, I'd have to divide the 10 by 4 as well. And that sounds really not so fun. Okay. So we have 384 right here. Now, b squared, we still don't have isolated, so we need to divide by 4 on both sides. Hey, there's b squared. And you can do 384 divided by 4, which is 96. That's not a perfect square, so we're going to have to take something out of it. And I do know that 16 is a perfect square that can go into 96. Why am I talking about that? Because we need to square root both sides. B equals, and then this is going to be, the answer really is like the square root of 96. But one thing to keep in mind here is that if I asked you what would be true for this statement here, a lot of people say 5. But there's another option. X could be 5 or negative 5. So that means that right after we square root on both sides, we need to account for the positive or the negative version of that square root. So now what I need to do is make sure that my answer is written as a simplified radical. So 96, like I said, 16 can come out. So let's rewrite this as the root of 16 times whatever's left, which is 6. 16 times 6 is 96. And then the reason why I pull out a perfect square is because that can be square rooted, that's 16. What's left over? The 6. And there is my answer. You can go an extra step and plug in both numbers, make sure that they both make sense. In this case, our answer is positive or negative for root 6. Okay, how about this one? So if I do the same steps, add 7, 3v squared equals negative 50, divide 3 on both sides, v squared equals negative 50 thirds, which can't be simplified. Oh man, so wow, we have, not only do we have a negative, but it's also a fraction. So that's why I chose this one for my harder problem. Okay, I'm doing the same steps as the other one. I need to square root both sides here. And I also need to not forget the plus or minus. But how on earth am I going to simplify a negative fraction under a square root? Okay. Well, one thing to remember is that the square root of the whole fraction is the same thing as the square root of each piece. So I can basically just simplify the top, the square root negative 50. Let's do that off to the side. So when I have a negative underneath the square root, I know that imaginary numbers are going to be involved. Here's what I recommend. Take out the -1, extract the I. Remember, I is equal to square root -1. Take out the -1, what's left? 50. And because that square root -1 is I, I'm going to just insert it right there. So that equals, and then what's the square root of 50? Well, it's not a whole number, but I can take out the largest perfect square, which is 25. What's left over? 2. And the way I'm going to write all that together is I can do, this is 5i root 2 as my answer. Okay, now I want to insert that here. 5i root 2 goes on top. Square root 3 goes on bottom. And oh man, there's something that still needs to be worked out. There is a root in the denominator, which is illegal. Okay, so this is called rationalizing the denominator. I need to get rid of the root somehow. Smartest way to do that is to multiply by root 3 on top and bottom. So I have plus or minus 5i root 6 over 3. Why is that? Because root x times root x is just equal to x. You know, if you're squaring square roots, then that would, that would balance out. We'd have like square root of x squared. That balances back out to x. So there is my answer. It had lots of layers to it. You can see that that's as hard as you get typically with square roots, for a possible ACT question. And the first one is significantly easier. Now, if you want to practice one of each, one that has the imaginary, one that doesn't, try these two. Why don't you pause the video before I reveal the answers? Okay, so the first one, it does require you to simplify a radical. The second one does involve I, but it is a whole number in front of the I, or I should say an integer in front of the I, because it's plus or minus. So I hope this video helped you in some way. Let's talk about the quote for a little bit of inspiration. Courage does not always roar. Sometimes courage is the little voice at the end of the day that says, I will try again tomorrow. Great, great, great thing to remember. So if you have an answer to the fun question, feel free to put it in the comments. And if you would like to keep up with new videos, feel free to subscribe. Have a good day.